All right. So good morning. I just want to start off by thanking Jim and Molecular Devices for the opportunity to come and present some new and exciting data that we've generated here at Eurofins. And so my talk is going to be looking at some GABA validation data on the IonFlux HT. So Eurofins is a leading partner for the pharmaceutical industry with over 190 labs in 36 countries. Eurofins Discovery Services, previously the Discovery and Development Solutions Unit of EMG Millipore, was acquired by Eurofins in April of this year. The Cell-based Assay Services Group within the Discovery Services Unit is based in St. Charles, Missouri, which is approximately 25 miles to the west of the city of St. Louis. Eurofins Discovery Services has an array of cell-based assay capabilities encompassing both products and services. On the product side, we currently have a library of over 60 precision ion channel cell lines and over 185 calcium-optimized cell lines. Our service offerings are extensive and cover a wide range of screening platforms, from a basic ion channel profiler assay service to many custom solutions. We can meet all of your cell-based needs. Today my talk will center around the validation of ion channel cell lines that we've developed here at Eurofins. I'm sure the dendrogram of the ion channel superfamily is familiar to many of you. And I just want to use it to inform you that Eurofins offers precision ion cell lines in the highlighted channel families. And today, my talk will center around the GABA family. So I will start with some background information regarding GABAA ligand-gated channels, followed by a brief review of the IonFlux HT. I will then present some validation data for the different GABA receptor subtypes on the IonFlux. And lastly, I'll compare the data generated on the IonFlux with that from other competing automated electrophysiology platforms. So the next few slides are going to provide some background information on GABA receptors. Gamma-aminobutyric acid is the endogenous ligand for these receptors, each of which is composed of 5 subunits to form a central cation-permeable pore. Each subtype has a minimum of 2 alpha and 2 beta subunits, matched with a third, which for today's sake will be a gamma subunit. The GABA binding site is at the interface between the alpha and beta subunits, and its binding causes the channel to open, allowing chloride ions to enter the cell. This in turn stabilizes resting membrane potential, making it more difficult for excitatory neurotransmitters to generate action potentials. The effect tends to be inhibitory. As well, other ligands can bind to the GABA receptor, modulating the action of GABA in opening the channel. And there can be ligand specificity between the subtypes, and that is thought to be mediated by the alpha subunit. A good example of this is Benzodiazepines, which bind the alpha and gamma subunits. They have different effects based upon which alpha subunit the receptor contains. For example, activity at the alpha-1 subunit is responsible for their sedative effects, while they're thought to affect their well-known anxiolytic properties via the alpha-2 and or alpha-3 subunits. And activity at the alpha-5 subunit is thought to affect cognition. It's important to point out that benzodiazepines do not bind at the alpha-4 and alpha-6 receptors, and this is due to a mutation in the alpha subunit that functionally abolishes the benzodiazepine site. So at Eurofins, we have recently expanded our range of ligand-gated ion channel cell lines expressing GABA subunits to include all 6 GABAA alpha subunits individually co-expressed with the beta-3 and gamma-2 subunits. And we run these cells on a regular basis, and this allows us to help troubleshoot your assays with our cells. We have offered GABA assay services for 7 years and counting here at Eurofins. And we offer a variety of platforms based on any throughput requirements. And these include IonFlux HT, Patch Express, and manual patch clamp assays for agonist, antagonist, positive allosteric modulator, and positive allosteric modulator antagonist. And I also want to mention we offer agonist and antagonist assays on the IonFlux Quattro. So the IonFlux is a high-throughput automated patch clamp system with the simplicity of a plate reader. And this is just to either refresh your memory or provide a brief introduction to the system as far as what it looks like and how the plates are laid out. Shown above here is the system, what the system looks like, and below is what an HT plate looks like, and it's essentially just an SDS 3-4-well plate with microfluidics stamped onto the bottom, and they are in these experimental patterns, one of which is highlighted in red, and there are 36 of them on one plate. 32, sorry. So each of those 32 experimental patterns is divided up into 12 wells, 8 of which can hold compounds. 2 are responsible for cell trapping, and the remaining 2 are responsible for the cell inlet and outlet, or waste. So what happens is the cells flow down this main flow channel and are pulled onto one of 2 cell trapping zones where up to 20 cells will be trapped and patched, and this can be seen in the picture below here. And then up to 8 compounds can be delivered to both of these traps, and this will generate up to an N of 8 in duplicate to give a higher data fidelity. So before we move on to the data, I just want to highlight a few key capabilities that make the IonFlux ideal for ligand-gated assays. It's also extremely capable for voltage-gated assays, but that'll have to wait for another webinar. First, the microfluidics allow for continuous perfusion as well as rapid and precise delivery of test compounds. Also, the cells are constantly clamped for the duration of the protocol. And the other thing to mention is the assay time. It's approximately a quarter of an IonWorks Quattro or Patch Express run. And this not only means more throughput, but the cells will certainly be happier, and we all can appreciate that happier cells equals more robust data. So we have validated all 6 GABAA alpha subtypes co-expressed with the beta-3 and gamma-2 subunits on the IonFlux using our Eurofins Precision GABAA cell line. The experiments were run in ensemble mode with the cells clamped at minus 60 millivolts. And we looked at current stability over time in the form of a time-matched vehicle. Looked at inter-run variability by running the same experiment over multiple days and comparing the IC50 or EC50 values. And also generated data for reference pharmacology in agonist, antagonist, positive allosteric modulator, and positive allosteric modulator antagonist assays. So here's some data for the GABA alpha 1 and alpha 5 receptors looking at current stability over time. And what we see here are representative traces for each of the receptors from single cell trapping zones. And these are the corresponding long-term record trace charts for each of them. And what we're doing is just repetitively adding the same concentration of GABA to the cells, and it's pretty clear that the currents are stable, very stable for the duration of the experiment. And this is something that's really important for the development of any of the assay formats that I'll be showing data for. So one of which here is an agonist assay, and this is just looking at the agonist response on the GABA alpha-1 cell line. And so what we want to show is that these cells will respond to increasing concentrations of GABA in a dose-dependent manner. And the traces that you see here are, again, a representative from just a single cell trap. And they are exposed to increasing concentrations of GABA, starting at 0.1 micromolar, going up to 100 micromolar. And what we see is, if we, the red trace is the 0.1 micromolar GABA, and it's about 500 picoamps. And as we apply increasing concentrations of GABA, we see that the currents increase in a dose-dependent manner up to approximately 12 nanoamps with 100 micromolar GABA. And so we can fit this data to a curve and calculate EC50 values. And we've run this assay over the course of 3 separate days and calculated EC50 values for each day, and that data is shown in the table on the right. And what we see is that the data is very reproducible over the 3 days, and it's also in line with the manual patch clamp literature value. So we also looked at the other GABA cell lines and their response to GABA, and here's that data. And we can see a clear dose-dependent response to GABA for each of these cell lines. At the top are the curve fits, and the bottom is the corresponding data table with calculated EC50 values. We also compared the EC50 data for the GABAA alpha-1 cell line on the IonFlux with that from other electrophysiology platforms. What we saw was that the GABA activity from the Eurofins Precision GABAA1 cell line is robust and reproducible across multiple platforms, including the IonFlux HT. So now let's take a look at some antagonist data for the GABAA alpha-1 receptor. And what we want to show here is that a reference antagonist will inhibit the current elicited by the EC80 concentration of GABA. And so the reference antagonist that we used was bicuculline, which is a nonspecific competitive antagonist. And again, the traces that you see here are the response of a single cell ensemble exposed to increasing concentrations of bicuculline, starting from 10 nanomolar going up to 100 micromolar. There's a 2-minute pre-incubation with bicuculline, followed by a 3-second application of the EC80 concentration of GABA. If we look at the traces, what we see is the red trace corresponds to the control current, or that elicited by the EC80 GABA alone, and it's approximately 12 nanoamps. And then as we apply increasing concentrations of bicuculline, we are able to increasingly inhibit that EC80 GABA current up to almost completely at 100 micromolar bicuculline. Again, we have a curve fit of the data showing a 5-point dose response. That's on the left. And again, as with the agonist assay, we've repeated this over 3 separate days and calculated IC50 values for each day. They are shown in the table on the right. And again, we can see that this assay is, and the data is very reproducible over the 3 days of testing, and it's also very much in line with the manual patch plant literature values. So here's the antagonist data for all 6 GABAA cell lines, and these data clearly demonstrate the ability to block the GABA current from all 6 of the cell lines in a dose-dependent manner with bicuculline. And again, at the top, you see the curve fit for all 6 GABA receptor cell lines. And at the bottom, you see the corresponding data table with calculated IC50 values. So benzodiazepines. They've been around for some time now and are well characterized. They bind to sites distinct from the GABA binding site, and they are responsible for allosteric modulation of the response to GABA and can functionally be either an agonist, antagonist, or inverse agonist. A key point to remember is that benzodiazepines have activity at all receptor subtypes with the exception of alpha-4 and alpha-6. So now we will look at the positive allosteric modulator response for the GABAA alpha-1 cell line. And what we want to show here is that the current elicited by the EC10 concentration of GABA can be positively modulated by diazepam in a dose-dependent manner. Once again, the traces that you see here are just from a single cell trap, and they're exposed to increasing concentrations of diazepam, starting from 1 nanomolar going up to 3 micromolar. And we have a 1-minute pre-incubation with the diazepam prior to a 3-second application of the EC10 concentration of GABA. And so if we take a closer look at the traces, the red trace corresponds to the current elicited by the EC10 GABA alone, and it's a little bit over 1 nanoamp. And then as we apply increasing concentrations of diazepam, we see that the GABA current is increasingly positively modulated in a dose-dependent manner up to approximately 4 nanoamps with 3 micromolar diazepam. So again, we fit this data to a curve, a 5-point, and we see a 5-point dose response showing a dose-dependent positive modulation of the EC10 GABA current. We've normalized the data to the control EC10 response and set that at 100%. And the highest concentration, 3 micromolar diazepam, gives a maximal potentiation of about 250%, or roughly 2.5-fold. Again, as with the other assays, we have repeated this on multiple days and calculated EC50 values for each day. That data is shown here in the table on the right. And again, we can see that the assay is very reproducible over the 3 days of testing and is also in line with the literature value. Here's the data for all 6 of the cell lines, and the data demonstrate the ability to positively modulate the GABA current in the alpha-1, 2, 3, and 5 cell lines, but not the alpha-4 and alpha-6 as we would expect. So, and again, the curve fits are on the top, and the corresponding data table with calculated EC50 values is on the bottom. So another assay that we took a look at is the PAM antagonist assay, and this can perhaps be also characterized as just a benzodiazepine antagonist, because you could look at it from the standpoint of a PAM response or a NAM or inverse agonist response. But in this case, we're just looking at the ability of a reference compound, flumazenil, to inhibit the GABA current that has been positively modulated by a maximal concentration of diazepam. Again, we have some representative traces from a single cell ensemble, and we expose this to increasing concentrations of flumazenil co-applied with the maximal concentration of diazepam, starting at 1 nanomolar going up to 10 micromolar of the flumazenil. And the flumazenil and diazepam are co-applied for approximately 1 minute prior to a 3-second application of the EC10 concentration of GABA. Looking at the traces, the red trace corresponds to the current elicited by the EC10 GABA alone, and it's about 1 nanoamp. And the orange trace corresponds to the positively modulated current as a result of the application of the maximal concentration of the diazepam, and that's about 3.5 nanoamps. And so that sort of defines the assay window. And then as we apply increasing concentrations of the flumazenil, we can see that we're able to increasingly block that positively modulated response of the maximal concentration of diazepam all the way back to the baseline EC10 GABA response. And so this can be more clearly demonstrated looking at the curve fit shown here on the bottom left. And we have normalized this again to the EC10 GABA response and set that to 100%. The maximal diazepam response is shown by the dotted line, and that's approximately 300% or threefold. And then we see the 5-point dose response clearly shows a dose-dependent inhibition of the diazepam-potentiated current by the flumazenil. As with the other assays, we ran this one on 3 separate days and calculated IC50 values for each of those 3 days, and that is seen in this table on the right. And just as with the other assays, this one shows very good reproducibility over 3 days of testing. So I also want to show some PAM antagonist data that we generated for the GABA alpha 5 cell line. And the assay format for this is the same as with the GABA alpha 1 data that I just showed. And on the left, you can see the dose-response curve fit, again, a 5-point dose response. And again, the data is normalized to the GABA EC10 current, and that's shown by the dotted red line and set to 100%. The maximal potentiation with the Emax diazepam is this dotted line here, and it's approximately 200% or twofold. And then we can see a clear dose-dependent inhibition of that potentiation by the flumazenil, and we calculate an IC50 value of approximately 28 nanomolar. Then on the right, we have a time-matched diazepam control response. And I want to show this because this is really key to any successful PAM antagonist assay, and it's why it's so difficult to achieve this on other platforms, but it's yet one other strong attribute of the IonFlux that we can achieve a very stable diazepam response over time. So the last thing we'll look at is the response of GABA receptors to barbiturates. Barbiturates are derived from barbituric acid, which was first synthesized in 1864. And they bind to sites on the GABA receptor, which are specific and distinct from the GABA site. They have three actions on GABA receptors: potentiation of the GABA response, direct activation of GABA receptors, and at high concentration, they can actually block the GABA channel. And they have activity at pretty much all GABA receptor subtypes, and this differs from benzodiazepines, and this is because the binding site does not involve the gamma subunit. So the reference compound that we looked at was phenobarbital, and we just looked at it on the GABA alpha-1 cell line. And what we want to show here is that we were able to pick up in this one assay two of those three barbiturate activities, one of which is positive modulation of the GABA EC10 current, and the other is direct agonism of the GABA channel. And so what we see here are, again, traces from a single cell ensemble. And the way that this assay is set up, the 5-point dose response spans two experimental patterns to do a pre-incubation and then a co-application with the EC10 GABA. So these traces on the left are the three lower concentrations of phenobarbital. Here's the EC10 GABA alone. It's around a little over 2 nanoamps, and then we can clearly see with increasing concentrations of phenobarbital that we're able to positively modulate that GABA current. Up here are the traces for the phenobarbital alone, and we can see at these three lower concentrations that we're not seeing any direct agonism of the GABA channel. But a little bit different story at the top two concentrations. Again, here's the current elicited by the EC10 GABA, and it's that 1.8 nanoamps. And then when we apply the top two concentrations of phenobarbital, 50 and 100 micromolar, we see strong potentiation of the GABA current. But we also see direct agonism of the GABA current with phenobarbital in absence of the EC10 concentration of GABA. And in fact, at 100 micromolar phenobarbital, the current elicited is actually larger than the EC10 GABA current. So here on the right, we have the curve fit of the positive modulation data, and again, normalized to the EC10 GABA, and that's set at 100%. And then we've calculated an EC50 value of 2.2 micromolar, which is in line with literature. And we have a maximal potentiation at 100 micromolar of approximately 300% or threefold. Looking at this bar chart here on the bottom right, we can visualize both the potentiation and direct agonism of the GABA alpha-1 channel by the phenobarbital. The blue corresponds to the potentiated currents, and the white would correspond to the direct agonism, just the phenobarbital alone. And so, again, we can clearly see direct activation of the channel at the top two concentrations and a nice dose-dependent potentiation of the GABA current as well. So in summary, we have demonstrated the effectiveness of the IonFlux HT for detection of agonists, antagonists, positive allosteric modulators and positive allosteric modulator antagonists of the human GABAA channel. Pharmacological data from the 5 assays shown are consistent with the literature, and the calculated EC50 and IC50 values were consistent over 3 days of testing for the majority of the assays shown. And the GABA current, GABA elicited chloride current is very stable over time, which is very important. And the addition of the IonFlux to our other platforms provides researchers in this field with another strong option to choose from to study these targets in depth. Now, I also want to mention that our validation efforts on the IonFlux are ongoing. And in addition to these GABA assays, which we have now, which we are now offering as services, we have also, my colleague David Way has generated some nice data, which most of you have probably seen on our 5 nicotinic acetylcholine receptor cell lines, and those assays are as well available for service. And we've also generated some data on a few voltage-gated sodium channels, as well as a purinergic receptor, P2X7, and we will continue to validate other targets as well, and hopefully bring more and more online and available for service offerings in the near future. So with the addition of the IonFlux, we at Eurofins now deliver fit-for-purpose GABA assays to our customers. And I just want to acknowledge the rest of the cell-based assay team here at Eurofins, and thank them for all their help and support. And I want to thank